Okay, so I hope you can hear me. Yeah. Hello. Hello. Can you hear me now? Hello.
Yes.
Okay. Okay.
We hear you, Professor.
Okay. Okay. So I share my screen, and today is our second day's online training session, and we already covered the first day, and I also put you the some assignment on this first day. So we will talk about the assignment about after our 2 hours live training session. Then we also talk about this. Okay. So now we will try to start our today's session. So I hope can you see my screen now? Yeah. Can you see my screen? Can you see my screen now? Yeah.
Yes, we see.
Okay. Okay.
We are seeing the screen.
Okay. Okay. So hi and welcome to the 7 days online training session on Google Earth Engine for remote sensing analysis for beginners to advanced training session, and we already covered our first day and today is our second day. Okay, so I am course coordinator. So this is our full course content with the 7 days online training session. We cover this full course content within the 7 days, all of the course content. So here you can see all of the course content I already discussed about this, and today is our second day, and second day course content will be that first of all I will try to discuss about that how you can easily filtering and displaying the satellite images, Landsat and Sentinel. So we already know about that Google Earth Engine has a lot of data set. So today we also try to discuss about that how you can easily filtering and the displaying the satellite images, suppose Landsat and Sentinel, how you can show on your filter for your specific region. Okay, then also try to discuss about the different types of band combination, suppose false color band combination, true colors band combination. We also try to discuss about this. Then also talk about the how you can easily export the satellite imagery from the Google Earth Engine platform. Okay, also talk about that how you can easily import and filter and reduce the and clip the display data in Google Earth Engine platform, and how you can easily make the time series chart, different types of parameter. It can be NDVI, NDWI, or any time series chart, how you can easily make the time series chart. We also try to discuss about this. Then how to export any shape file. Okay, so how you can easily export the any shape file, we also try to discuss about this. And then how to calculate it any indices from the satellite images, how you can easily calculate any indices from the satellite images. Suppose you can take the Landsat image or Sentinel image, and then you want to calculate it the NDVI, NDWI, or any other indices. We also try to discuss about this. So this is our today's course content. We also try to start step by step and try to finish all of the things. Okay, so let's go. First of all, Earth Engine public data catalog. So we already know about that. Earth Engine has a lot of public data set. We can easily use freely this data set. Here you can see we can get the data set Landsat, Sentinel, and different types of Landsat and Sentinel. It can be raw, it can be top of atmospheric or surface reflectance. Lot of collection we can easily get from the Earth Engine public data catalog. Also we can get the different types of MODIS satellite product. It can be daily, LST, or NBIR, or train. Okay, so kindly mute your sound, so it will be benefit for me. Okay, so kindly mute this. Okay, and then you also get the different types of train data set, suppose SRTM, and then lot of data set. Also you can see land cover data set, atmospheric data set, and many more and it's daily updating. So this data set is updating daily. Okay, and you can, here you can also access more than 200 public data set, more than 4,000 new images every day. Every single day you can get here more than 4,000 new images. Also you can get the more than 5 petabytes of data, and more than 5 million images you can easily access, and you can freely use this dataset in Google Earth Engine platform. Okay, in this time here you can see I also try to show you this, the link. Here you can see this is the link, and this is the link for the Earth Engine public data catalog. When you can simply go to this link, you can easily access all of the dataset. Okay, so in this time I simply go to this dataset. Suppose I simply copy this link from here, and then I simply open in my browser. So now I simply open a new browser in here and try to open this. So I simply open a browser. You can see now, you can see all of the Earth Engine public data catalog in here. So it will be opened, you can see. So I think in here the network connection is not so good, so that's why it takes some time. Okay, so now we can see it appeared our all of the Earth Engine data catalog. Here we can get all of the data set. Here you can see the climate and weather data. We can get the surface reflectance data, also get the climate data, also get the atmospheric data, weather data, different types of imagery, Landsat, Sentinel, MODIS, high resolution. We can get the train, land cover data set. Also you can see the cropland data set, other geophysical data set. We can easily get all of the data set. Also you can see this is the Landsat. When you click here the Landsat, here you can get all of the Landsat collection. Here you can see all of the Landsat collection. You can see the Landsat 9 surface reflectance, Landsat 8 surface reflectance. Also you can see Landsat 7, 5, 4, Landsat 9 for top of atmospheric, Landsat 8 for top of atmospheric, Landsat 7 for top of atmospheric, raw image. Actually we can get all of the data set for the Landsat. Also you can see the Sentinel. So when you want to work with the Sentinel, so here you can get all of the Sentinel image collection. Here you can the Sentinel 1 SAR, also you can see Sentinel 2 multispectral, Sentinel 3, also you can see Sentinel 5. Okay, also you can see dynamic world dataset. Okay, so also you can see this is the world cover or land cover dataset for the Sentinel dataset. Okay, also you can see cloud probability dataset. Okay, also you can see global map of oil palm plantation. Okay, so there are the lot of dataset in here. Okay, so also you can see the MODIS. So here you can get the lot of MODIS dataset about the different types of. Also you can see this is the MODIS dataset. Okay, lot of dataset. You can see this dataset for the land surface temperature. Okay, also you can see different types of dataset you can easily access. Okay, so in this time I also try to discuss about this part, how you can easily work with this dataset and make the map in Google Earth Engine platform. So in this time I also try to show you this task. So I simply open my slide and try to show you this. In this time I will try to discuss about that, how you can easily import, filter, reduce, clip and display the data in Google Earth Engine code editor. So here you can see I how to import the data from Earth Engine dataset, then how to filter this dataset, then how to reduce this image collection, and how to clip on your shapefile, and how to display the result on the map, and how to reproject it the scale pixel value. Okay, so I also try to discuss about this. So I simply go to my code editor. Suppose you can see this is the data set. This is the data vegetation index is 60-day global 200 meter resolution. I want to work with this data set. So first of all, I simply click to here. You can see this data set. You can get all of the data set information. You can see this is the description. Here you can get all of the information about this data set. Also you can see this is the band. Okay, so what is the band? You can see this data set has a two band. We can say that NDVI. You can see this is the NDVI and EVI. Okay, this is the NDVI and EVI. Okay, so here you can see this is the two bands I can easily access from this data set. NDVI, this is the normalized difference vegetation index, and EVI, this is the enhanced vegetation index. Okay, so in this time I want to work with this data set. So for this I need to import this data set in my code editor. I can do this two way. I can simply copy the Earth Engine snippet. Okay, I simply copy this Earth Engine snippet. I simply copy. Also you can see this is the data set availability date. We can get the data from the year of 2000 to present time. We can get this data. This is the data set provider. Okay, I can simply copy the Earth Engine snippet from here. Simply copy, and then I simply open this Earth Engine snippet. Just paste in my code editor. Okay, so I simply copy it and then simply paste in my code editor, and then I simply take a variable in here. I simply take the variable. Suppose this variable name is that. I simply take the variable. Suppose this variable name is that. I can simply put the variable name is the suppose modis. Okay, you can use any name, no problem. Variable name you can use any name. So in this time here you can see this is my collection. Okay, and I simply put here the modis. This is the variable name. Variable name can be anything. In this time, this is my full collection of the modis data set for NDVI. It is stored in a variable modis. Okay, I can simply search. So this is the one way, and another way is that you can simply search the data set in here. Simply search the modis NDVI. Okay, simply search here, and here you can get this data set I want to use here. You can see Terra vegetation indices 60-day global 250 meter. I simply clicked here. Here I can get all of the information about this data set. Here you can see this is the description, this is the bands. Also you can see all of the things will be same. Okay, so I simply click to the import. This data set also imported. So this is the two way. When you want to import the data set in Earth Engine code editor, you can simply copy the Earth Engine snippet, or simply search in here and then click to the import. Then this data set will be imported here. So can you guess it? What is the variable name in this line? In this line, what is our variable name? Can you guess it? What is our variable name in this line? Anyone? Can you guess it? What is our variable name in here?
MODIS.
So here you can see this variable name is the image collection. After the var keyword, what is the name? This name called the variable name. You can see this is the also variable name modis. This is the also variable name image collection. Okay, so this is the default variable name image collection. Okay, and also you can see this is the modis. I write this. So there is the two way. If you want, you can use any one way when you want to import the data set. This is my data set. I want to import this data set in my code editor. I can do this two way. First way is that I can simply copy this snippet and paste in my code editor and put in a variable name. Okay, or I simply search in the top of the code editor. This is the search bar. Simply search and then simply click on here my dataset and click to the import. This dataset also imported. Okay, so this is the two way you can use any one way for importing your collection. Okay, so we can easily use the any two way, and we can easily make the import our data set. So here you can see I simply use the first way. You can see I simply imported my data collection and I simply rename this. You can use any name. I simply put the name is the modis. Okay, no problem. Variable name can be anything. So in this time here you can see this is my image collection, and this image collection is stored in a variable. This variable name is the modis. Okay, I import my data set. In this time here you can see this data set has a two band, NDVI band and EVI band. In this time I want to select my specific band NDVI. So I simply take a variable and give the variable name is the modis NDVI. You can use any name, no problem. I simply use modis NDVI. Then I simply call my collection. You can see this is my collection of modis. Okay, and what is the variable name? This variable name is the modis. I simply copy the variable name and paste here. Okay, after this I simply use here the select function. Okay, and then what I want to select? I want to select my band NDVI, because in this time I want to make the NDVI map. Okay, so I simply select my NDVI band. In this time I want to check how many images will be available for the whole world between this time period, year of 2000 to present time. How many images will be available for the NDVI? I want to check it for the whole world. I want to check it. I simply use here the print function. Print, and then simply call the modis NDVI. Okay, then I want to simply use here the size function. So size is a function. It's determine how many images will be available. You can see how many images will be available in here. I can get the result 503 images for the year of 2000 to 2020 9th May. I can get total 503 images in here. Okay, suppose I want to need only for the 1 year or 5 year or 2 year. Okay, I want to select my specific time period. I don't need the whole year of 2002 present time. I don't need this time period. I need the image, suppose year of 2015 to 2020. I want to need the images between this range. So I need to filter this. So I simply take a variable. Take the variable. I simply use the variable name is that suppose I simply use here the filter NDVI. You can use any name, no problem. Then I simply call the modis NDVI, because this modis NDVI is stored total 503 images. I simply copy the modis NDVI and paste here. After this I simply use a filter date function. This function is that filter date, and you can see what is the argument. We can get the argument start date and end date. I simply make here the start date, suppose year of 2015 1st January. Okay, from I simply put here the suppose year of 2020 1st January. Okay, so I can get the data total 5 years from year of 2015 to 2020. I can get total 5 years NDVI data. Okay, so now I want to check how many images will be available in here. So I simply use here the print function, and then I simply call the filter NDVI. Okay, and then I simply use here the size function, and then click to the run. So now you can see how many images will be available between this time period. I can get the total 138 images is available for this time period for the whole world. Okay, in this time I want to check when this image will be captured. I want to check that this time period or date. So you can see I can simply print this filter NDVI. In this time it's showing me all of the date. From the feature I can get this date. Here you can see first image is captured year of 2015 1st January, year of second image 2015 17 January, then 2nd February, 18 February, 6 March, 22 March, 7th April, 23 April. We can get every images interval date. You can see interval 16 day. So that's why you can see this dataset called the 16-day. Okay, this dataset called the 16-day global 250 meter resolution. So that's why I can get the every images interval date 16-day, 16-day, between 16-day, also 16-day. Okay, all of the image you can see. First image taken the 1st January, second image taken the 17 January. So this is the interval date 16-day. I can get this dataset the 16-day average NDVI value. Okay, so in this time, from this 138 images, I want to calculate it the average NDVI. So that's why I simply take a variable and give the variable name is the mean NDVI, mean NDVI, and then I simply call the filter NDVI. In this time, I want to reduce this image collection. I simply use here the reduce. Then how I can reduce? I want to reduce it dot reducer dot mean. Okay, so now I want to show the result in here. So you can see in this time I want to calculate it the mean of all images that we get after the applying the filter date. We will use the mean reducer to our data in this time, which reduces the image collection by calculating the mean all average of all values at each pixel across a stack of all meshing band. So now I want to show the result. So I simply use here the map dot add layer. In this time I simply copy the mean NDVI and then simply paste here and then click to the run. You can see I can get the whole world NDVI map, but I did not add any visualization parameter. So that's why first time I can get the totally ash color map. Here you can see I can get the map ash color. So in this time I want to add here some visualization parameter. So that's why I simply go to here, and they are already provide some visualization code. I simply copy from here. Just I copy and then I simply paste in my code. So here you can see in this time they are make a dictionary in this code. They are make a dictionary. You can see they are make a dictionary and they are put the mean NDVI value. It will be start from the 0 pixel and max pixel NDVI value up to 8000, and they are also put here the some color plated. Okay, and it is stored in a variable NDVI viz. I simply copy this variable name and then I simply paste after the object name. So this is the object name. I simply put after the object name and then click to the run. So now you can see what happened. So now you can see it's showing the NDVI map for the whole world. Okay, mainly NDVI map is identify the where the dense vegetation is located and where is the low vegetation is located. So here you can see this is the full world NDVI map. It display, so it display the result. You can see, let's display our data on the map. We can see how fast it works. We have calculated the average of all images between the year of 2015 to 2020 within a second. Okay, we can get the NDVI map. Okay, you can see this is our NDVI map for the whole world. In this time, suppose you don't need the whole world, you need only for your own country. You want to need only for the own country. What is the condition of NDVI of China? You want to calculate this. Okay, so for this you need to simply import your shapefile. You need to simply import your shapefile, and we already covered this part how you can easily import the shapefile in here. So in asset tab, in this time I want to use the dataset US dataset. This dataset provided all country boundary shapefile. Okay, so I simply import the dataset for getting my shapefile or country boundary shapefile. I simply take a variable and give the variable name is the country. You can use any name, no problem. Then I simply call my table because it stored my full international country boundary polygon. I simply use here the filter. Then how I can filter? I want to filter Earth Engine filter. Then equal, what's equal what, I simply put here the country name, then put here the, suppose country name is that, I can simply put here the Bangladesh. Okay, and now I also want to focusing this shape file, so I simply use here the map dot center object, and then I simply use here the country, and I put here the 10 zoom level. In this time here you can see I simply imported my shape file, okay, in this variable country. So in this time I just simply clip with this, so I simply take a variable, this variable name is the study area, I simply put the study area, and then I simply call the mean NDVI, simply call and paste here. After this I simply use here the clip function, it will be clip with my country boundary shape file, and this shape file is stored the variable country. I simply copy the country and then I simply paste here. Okay, and now this is my final object, I simply copy and paste here and then click to the run. So now we can see it display the data only for the country boundary of Bangladesh. We can get the NDVI map of Bangladesh. So here you can see. This is the NDVI map for Bangladesh. Okay, so now you can easily export this map and make the map layout or other things. So you can see you can easily export this map and you can easily make the map layout from here. So I also try to show you that. So here this map. Okay, so here you can see this is the one map of NDVI. So I simply open this NDVI map. Here you can see this is the NDVI map, okay, and this map I created in Google Earth Engine platform. You can see like this, I just created this tip image, and from this tip image I just download this tip image and this created this map layout or other things like this in the ArcMap software. For making this title, legend, scale, legend, all of the things I can easily do in ArcMap software for making my research paper, as well as also my presentation work, for I can easily make this. Okay, so you can easily download these tip images. Okay, you can easily download these tip images and make the map layout like this, make the map layout and other things like this for your research paper as well as also your presentation work. So I also try to show you that how you can easily download this tip image and make the map layout like this. So that's why you can easily understand about this. Okay, so in this time you can see this is our result. Suppose you need the result for your own country, China, you can simply put here the China and then click to the run. So now this is it showing the NDVI map of China between this time period. Here you can see it will be loaded, this map for the China. Okay, so you can see this is the NDVI map of China. So here you can see this is the very less vegetation region. Also you can see some of the dense vegetation. Okay, Also you can see this is the very less vegetation, and there is no vegetation in this area. So here you can see this is the NDVI map of China between this time period, year of 2015 to 2021. We can get this China NDVI map. You can easily export this map and easily make the map layout or other things using the ArcMap software easily for your research paper as well as also your presentation work. Also you can see, suppose I want to need the map for another country. Suppose I need the Australia. I simply use here the Australia and then click to the learn. So now you can see it's showing the Australia NDVI map. Okay, so you can see it's showing the Australia NDVI map. Okay, suppose you any country in the world, you can easily get this NDVI map. Just you can put the country name. Suppose you need the country map for the Pakistan and then click to the run. Now you can get the country for the Pakistan. You can see. And we can easily identify the vegetation condition of this region. We can easily identify it. So here you can see. And we can easily download this and make the map layout in here. Okay, so in this time here you can see this is our NDVI map. We can easily get the NDVI map, but this NDVI map has a problem. This problem is that we already know about the NDVI map. NDVI range always -1 to +1. So you can check what is the NDVI range. You can check NDVI range. NDVI. You can see NDVI value range. So now it will be showing the NDVI value range. So this is the, you can see this is the NDVI value range. We can see the NDVI value range between, you can see, +1 to -1. We can get this NDVI value range +1 to -1. Okay, but in this time when I want to check the NDVI value in here, you can see when I click to the inspector tab. So mainly inspector tab is working for when you want to click here, you can get the map querying result. So when I click to here, you can see I can get the result like this. You can see 5832. Okay, so it's not accurate NDVI result. It's, you can see, we already know about that. What is the NDVI value range? +1 to -1 or -1 to +1. But in this time I can get this result. You can see I get the result like this 5832. In this time I want to reprojected this scale value. I want to reprojected this scale value, and how I can reproject this scale value in this time I want to show you this. Okay, so for this, when you want to make the reprojected this scale value and you want to get the accurate scale value between the -1 to +1, then you need to know what is the scale value. You can see this is the NDVI band, and this NDVI band has a scale. You can see this is the scale. Okay, this is the scale. In this time I want to create a function, then this function is multiply all of the images which I get, all of the images multiply with this scale. You can see this is my scale. Okay, so in this time I want to just multiply with this value with my all of the images which I get. You can see here I can get total. Here I can get total. I want to check it. You can see here I want to get total. After filter NDVI, here I can get total image. I want to check it. I can simply use here the print function, and then I simply use here the filter NDVI, and then I simply paste here, and then I simply use here the size function. It's determined how many images will be available here. So here you can see here I can get the 138 images, but this 138 images is not reprojected. it's not reprojected. Okay, so that's why I can get the result like this. It's not which I did not get the result between the positive 1 to negative 1. I can get the result like this. Okay, in this time I want to just multiply this 138 images, all of the images I want to multiply with my scale. This scale is that 0.0001. Okay, not only for the one image, here you can see total 138 images you need to multiply. So for this, in this time you need to use here the function. So we already know about the function. Function can be reuse our code and make it easier to read. So function, mainly we use the function reuse our code. In this time I want to make a code, so that's why this code multiply all of the images with this scale factor. All of the images will multiply with this scale factor. In this time here you can see total 138 images. So in this time this 138, all of the images is multiply with this value 0.0001. So then I can get it will be reprojected, because in this time I want to multiply with my scale value, and in this time here I use the function. Okay, so I already know about the function. I want to show about the function how we again. So you can see in this time I want to create a function. So for this okay, so let's go. So we will create a function. So for this, okay, so kindly mute your sound. So that's why it okay. If you have any question anytime, you can just let me know, then you will unmute your speaker, then talk, no problem. But otherwise you always keep your shut down. Okay, no problem. Okay, so in this time here you can see I will try to calculate it the all of the images here, 138 images I want to multiply with my scale factor. So that's why I need to create a function. So I simply take a variable and give the variable name is the scaled NDVI. Okay, in this time I want to scaled NDVI, so I simply make a function. I simply use the function keyword, and then I simply put the element name, suppose image. You can use any name, no problem. I use here the curly bracket, and then what I want to argument. My argument is that I simply use here the return function. I want to argument is that image multiply. I use here the multiply function, multiply with my scale factor 0.0001. Okay, and then you can see in this time this is the image, it also image, not image. Okay, image. In this time this is the image. Okay, I just one image, you can see this is the one image. I simply use the one element name image. So I want to use this I want to use a function. This function multiply all of the images, total 138 images, which I get between this time period, year of 2015 start date and end date. Okay, this time period I can get 138 images. In this time this scale factor 0.0001 I want to multiply all of the time period image which I get. Okay, so that's why I need to use a function. It's called the copy properties. Copy properties. What I want to copy it? I want to copy it this image. Okay, then I also need to define here the system, because I want to need all of the images. I can simply put here the system time start, also put here the system time end. Okay, so here you can see I created this function. In this time you can see this is the single image. I take the only for the one image. This one image I multiply with my scale factor. This is my scale factor. Then I want to make a copy properties function. So that's why all of the image is multiply which I get between this time period, system time start and system time end. And what is the system time start? Here you can see I already defined the system time start date, and system has also end date. Okay, so now it just multiply with this scale factor, is just multiply with this scale factor all of the images, then I get the total reprojected this scale value. In this time you can see I create the function, but it has the no relation with the filter NDVI. I create this function, it has the no relation with the filter NDVI. Okay, so in this time I want to connect this. So you can see I created this function, but this function has the no relation with the filter NDVI. So that's why in this time I want to connecting. So that's why I simply copy this variable name and paste here. After this I simply use here the map function, and also use here the parenthesis map function. So now you can see this function I created, and I add this function with my filter NDVI, because this filter NDVI stored total 138 images, total 138 images. So this filter NDVI is my whole collection. I created this function, I add this function with my whole collection. So that's why I simply use here the map function. Okay, so now if you have any question or any doubt, you can ask me. Any question or any doubt, anyone, you can ask me, no problem. Any question about this function? Any question, you can ask me. Any question or any doubt about this?
No.
Okay, and after completing this training session, I also provide you this video recorded classes, as well as also you can get the practice code. So when you practice, when you face any problem, just let me know, then you can also get support, no problem. Okay, so in this time you can see I reprojected this scale value. So I can easily, now I want to work it how many images will be available after reprojected. I simply use here the print function, and then I simply copy the scale NDVI, just simply paste here, and then I simply use here the size function again. So now you can see how many images will be available after scaled value. You can see after multiply this, we can get the same result, 138 images. Okay, you can see before I want to get the 138 images, and when I applying the scaled NDVI, I just multiply with my whole function, then I also get the 138 images. So it reprojected our scale value. So it reprojected our scale value. In this time I want to work with this scale NDVI, this data set. Then I created this map, and then I can easily export this map, and you can see I can easily get this export this map like this. You can see I easily get this map like this. Okay, when I export the map and make the map in ArcMap software, then I can see I can get the range between this. You can see this is the range between the -1 to +1. I can get this map, and you can easily use this map for your research paper, as well as also you can use this map for your presentation work. We can easily do it. Okay, so in this time I want to just reproject this value, and now I want to show this in this map and reproject it, how we can easily reproject this map. Okay.